Hi, my name is Jeff Levine. I'd like to welcome you to this webinar entitled Getting to Know AWS Secrets Manager. I am a Senior Solutions Architect in the Security and Compliance team at Amazon Web Services. First, just a little bit more about me. For history's sake, the first computer that I used was an HP 3000 Series 2. I have used key punchers and card sorters. You might find those in museums today. My first programming language was Fortran. I came to Amazon Web Services in 2016, and I help customers with real-world security issues. I write blog posts and white papers, and I love to scuba dive. So now let's move into our presentation. Today we'll talk about foundations of Secrets Manager, the lifecycle of secrets, how they're stored, rotated, audited, and deleted, challenges with Secrets Manager and how to address them, and then we'll talk about some demo code and a presentation, and there will be time for Q&A later. Let's talk about foundations first. First, a secret is a piece of information that's meant to be hidden because knowledge of that secret can have undesired consequences. So in the world of InfoSec, a secret is used to gain access to additional information. Consequently, we need to be able to control the access to our secrets, and we need to be able to audit the access to our secrets. Examples of secrets in AWS include things like database usernames and passwords. That's specifically what we'll be addressing in the demo that we do later today. But they could also be application usernames and passwords as well. So what are the main benefits of Secrets Manager? First, it supports the complete life cycle of secrets management. That includes storage, rotation, and auditing. And it includes native support that's out of the box, so to speak, for Amazon RDS and Aurora. But you can also extend the Secrets Manager's functionality to include other credential sources, such as application credentials with rotation functions built on AWS Lambda. And for those of you who aren't aware of that, AWS Lambda is the serverless computing platform for Amazon Web Services. And we developed Secrets Manager based on the experiences that we at Amazon have in managing millions of secrets globally. When you have to keep track of them and rotate them, we've learned over the years what capabilities are needed, and we incorporated those into Secrets Manager. So now let's talk a little bit about the life cycle of secrets. First, in terms of storage, all secrets are encrypted by KMS using either the default service key or a customer-managed KMS key. You can attach identity policies to users, groups, and roles to control access to a secret. But furthermore, you can also attach a resource policy to a secret to determine what principals can access the secret. So think about it as putting policies at both ends, on the principals who want to access the secret, but also on the secrets themselves. And the identity policies and the resource policies have to be satisfied in order to grant access. So the principal needs to be able to access the secret, and the secret needs to allow itself to be accessed as well. The two of those policies have to meet in order to grant access. A little bit more about storage. Secrets are versioned. So this allows you to go back in time and fetch previous versions of the secret if needed. So for example, if you have to retrieve an old version of a resource like a database or an application table of some sort, and you need to get a previous version, you can do that with Secrets Manager. And secrets also have what we call staging labels. You can think of these as attributes that can be used to identify versions of the secret. And AWS uses special staging labels during the rotation process. And when we go through our demo today, we'll talk about those. Now let's talk about rotation. And this is one of the main benefits that Secrets Manager brings. Secrets Manager rotation is handled by Lambda functions. Again, Lambda is the serverless compute platform on AWS. And AWS provides functions for native RDS and Aurora rotation. So MySQL, PostgreSQL, and so forth. All of those are provided out of the box. You don't need to do any coding whatsoever. The native rotation functions are derived from templates in the serverless application repository and are instantiated via CloudFormation. I'm only mentioning this because when you enable Secrets Manager rotation and you go to your CloudFormation console, you'll see an extra CloudFormation stack that appears that represents that serverless application repository that has been accessed to build a Secrets Manager rotation stack. You can also build your own Lambda functions to meet your unique rotation needs. A little bit more about rotation. When a rotation is initiated, Secrets Manager generates a new credential with identical privileges and attaches the AWS pending staging label to it. So that's a reference to that staging label concept that I mentioned before. And then Secrets Manager tests that credential. If that credential is successful, if it can log in the way it's supposed to, then Secrets Manager also attaches the AWS current staging label to it. And then after that, the AWS previous staging label is then attached to the previous version. So this gives us a way to identify the current, pending, and previous versions of a secret. And if a problem arises, you will be able to use the staging labels to help you recover. So again, this is part of what we've learned at AWS in terms of managing secrets on a large-scale basis. These staging labels will help you not only with the actual rotation, but in the event a recovery is needed. Let's talk about rotation functions and how networking fits in. So in order for rotation to happen, the rotation function has to be able to communicate with the protected resource. So an RDS database or an Aurora database and so forth. But it also has to be able to communicate with the Secrets Manager service itself. So again, you see in this diagram, this two-pronged communication that's needed by the Lambda function to Secrets Manager and to, in this case, Amazon RDS. If the protected resource is not publicly accessible, what Secrets Manager will do is bind the rotation function to the VPC, and then all communication will happen within the VPC. This is the preferred way to do it because this way all of the communication stays private and does not have to traverse the internet. If the protected resource is publicly accessible, by default, Secrets Manager does not bind the rotation function to the VPC, and communication does not reside solely within the VPC. You can customize this behavior a little bit by making modifications to the network parameters of the VPC itself and of AWS Lambda. So the preferred way of accessing Secrets Manager is through VPC Interface Endpoints, but there are some caveats that you have to be aware of when you begin to use them. So when you use a service like Secrets Manager that offers VPC Interface Endpoints, you have to look up the AZs that offer the endpoints and create subnets in those AZs. And remember that not all AZs within a region offer interface endpoints to a service. So again, be aware of the fact that interface endpoints are not necessarily available in all AZs, so you do need to look them up and design your architecture around this. Also remember that AZs are mapped differently per account. So if you're an organization and you have multiple accounts, for example, US East 1A is not necessarily the same physical data center for each account. So you need to look up the AZs for your account to see which AZs offer the appropriate interface endpoints. Also, I suggest you enable private DNS to make it possible to access the service via its default name. And to do this, there are some attributes in the VPC you need to set, enable DNS host names, and enable DNS support, and set those to be true. Alternatively, you can access the Secrets Manager endpoint through the public internet. If you want to do this, you would need a NAT gateway, and the traffic would exit the VPC encrypted, but it would exit the VPC to access Secrets Manager. We do not recommend this approach. Again, the preferred way of accessing Secrets Manager is through VPC Interface Endpoints. In terms of auditing, Secrets Manager is integrated with AWS CloudTrail. It will capture all the APIs for Secrets Manager events, including both from the console and from code. And it can work with CloudWatch events to trigger alerts when administrator-specified operations occur. For example, if someone goes and deletes a secret, you may want to trap on that and alert. Or also, if someone is accessing a secret that is pending deletion, you may want to trap on that as well. Let's just say a few more words about deletion. AWS Secrets Manager does not allow you to immediately delete a secret. You schedule the deletion for a minimum of 7 days in the future, and you can cancel the deletion of the secret at any time prior to its actual deletion. Now let's talk about challenges that arise and how to address them. The most common challenges are related to the topology. So again, make sure that your rotation function has access to the Secrets Manager endpoint as well as the resource that is being rotated. Also, the preferred way, as we said before, to establish connectivity to the Secrets Manager is through the VPC endpoints. And establish subnets in the AZs that offer the endpoints. If you don't have a subnet in those AZs, you won't be able to communicate through the VPC over to Secrets Manager. And remember again to turn on private DNS in the VPC to simplify the resolution of the service point name. And then make sure your rotation function can access the private resource itself. Also, check the rotations function access to the VPC too. Another challenge that arises is the matter of conflicting IAM policies. You want to examine the identity policies that are applied to the IAM principals, the users, groups, and roles that come into play, and examine the resource policies that are applied to the secrets. Again, remember the identity policies and the resource policies need to match. They need to give access both to the principal and to the secret itself. And again, as I said, make sure the intersection of the two allows the access that you need. So now we're going to walk through some demo code and then actually do a presentation of the demo. This demo is located in GitHub in the AWS samples repository under AWS Secrets Manager Workshop. And we're going to do module 1 of the AWS Secrets Manager Workshop, and it's entitled Rotating the Secret for a Private Amazon RDS Database. So let's talk a little bit about what we're going to build here today. We have a VPC that's in US East 1. It has 2 subnets, and it actually has one subnet that's visible here and one that's not, and I'll talk a little bit about why. We have a Bastion host that is running on Amazon Linux 2 in EC2. And we also have a database, an Amazon RDS MySQL database that's called Book Info. And we also have a Secrets Manager endpoint here as well. There's actually another subnet that I'm not showing here because when you set up an RDS database, you do need a second subnet for the subnet group, but we're not actually using it, which is why I don't have it depicted here on this diagram. So let's talk about some of the considerations that are within the code. We need to provision subnets and availability zones that offer AWS Secrets Manager endpoints. I've made this point a couple times, and I want to emphasize it because it's very important. Again, not all AZs offer the endpoints, so we need to look them up. Also, I am creating random usernames and passwords for demonstrations like this one because I don't want to have a situation where we have a default username and password in case for any reason the VPC were to become unprotected, perhaps by changing a security group. I just want to make sure that we don't have default passwords out there. Here's an excerpt of the code that is in the CloudFormation template. And you can see here that there's a resource type here called custom. So what we're defining here is a custom resource that is going to look up the endpoints that are available for a given service. And the custom resource capability of CloudFormation allows you to extend CloudFormation by adding additional functions to it, which are powered on the back end by Lambda. And so while this webinar is not meant to be a comprehensive course on CloudFormation, I just want to say here that we're passing two parameters. Number one, the name of the endpoint that we're looking for, which in this case is com.amazonaws.us East 1 Secrets Manager, and the number of AZs that I want to make sure exist that offer the endpoint. And I'm saying 2 here because, as I mentioned before, a subnet group for RDS needs to contain 2 AZs and therefore 2 subnets. And so what I do in my CloudFormation Python code that's making up my Lambda function is I use the describe VPC Endpoint Services API to look up the service that I just mentioned, namely Secrets Manager. And you can see right below there that I pick off the returned availability zones from the response array, as well as the number of AZs, and I use the length function to do that. And then I return the AZs using the join method to separate them by commas, and I also return the number of AZs as well. And then I use that information in the main part of my code by calling the getATT intrinsic against the returned value for my VPC Endpoint Services function using the AZs element that is returned. So essentially here I am picking off the first and second AZs to create my subnets and subnet group. And then at the bottom, when I create my DB instance, I'm also pulling off the first subnet as well, the first AZ as well, that's returned from the function. Now, I also have another function in my code called random string function, which, as its name implies, generates a random string value. You simply pass it the length of the string that you want to generate, and I use this for creating usernames and passwords. I'm not going to go into the details of how that function does what it does, but you can take a look at it when you look at the Python code that's contained inside the CloudFormation template. Again, everything is all within the CloudFormation template, the main CloudFormation code, as well as the Lambda functions. So now what we're going to do is to move into the demo. So I'm going to exit my PowerPoint presentation here and switch over to a set of browser windows that I have that we will be using here today. So if I go ahead and create this, if I want to go ahead and run the demo, I go into CloudFormation and I select Create Stack. Now, you can see here that I have already selected the file one_rotate private rds.yaml. And if I click Next, CloudFormation parses that template, and then I can say something like Secrets Manager demo test. I have to have a key pair ready, and then I click Next. CloudFormation prompts me for a few more things. I don't need to change anything, so I click Next again. And if I click to acknowledge that I am going to be creating IAM resources, and then if I were to click Create, CloudFormation would then go ahead and build this whole stack for me. Now, because we're having a webinar, rather than waiting 10 to 15 minutes for this stack to build, we're going to pretend like this is one of those TV cooking shows, and we're going to switch over to a stack that I have already built that has this information already populated in CloudFormation. So I have my SM Demo webinar stack here. And the first thing that I'm going to do is look at the outputs of that stack. And when we look at the outputs of the stack, we see a couple of things here. We see a DB password and a DB user. These are going to make up the values for the credential that I'm going to be storing in Secrets Manager. And then we have a database endpoint, which I won't actually use in the demo. And then we also have a bastion IP. This is the IP address of that host that I had created as part of the CloudFormation stack. Now, you'll need a program on your system. In this case, I'm using Windows, so I have a program called Putty, or Putty, depending on how you pronounce it, which allows you to open up an SSH session to a host using a private key. So I'm going to bring that up. I already have that here. So let's see, that's all running fine. So now what I'm going to do is go to our Secrets Manager console, and I am going to store a secret. Now, it's going to want the username and password that I'm going to associate with the secret. So again, I have to get that from my CloudFormation outputs. So I'm going to copy the value that I see here for DB user. I'm going to paste it into my username. And what I suggest you do when you're doing this yourself is just make a note of what the first and last characters are so you can make sure that you copied and pasted correctly. Now, we also have to do the same thing for the password. So I'm going to copy over now the database password. I'm noticing that it begins with an A and ends with a G, so I'll copy that. Just for the sake of making sure I did this right, I'm going to turn on Show Password so I can visually see what it is. And I can make sure I've copied it correctly. I'm going to use the default KMS encryption key for the sake of this demo. And then I have to pick the database that I want to apply this secret to. So this is the database that was created. It's a MySQL database that the CloudFormation template created. And I'm going to click Next. I need to pick a name for the secret, so I am just going to call it SM Demo. And for my description, I'll say SM Demo Webinar. You don't even need to put a description in, but I'll just do it anyway. I'm going to click Next. Now, I'm going to leave rotation disabled for now. I just want to store the secret. We'll enable rotation later. I'll click Next. You can see it shows me what parameters I've already entered. And then if you want some example code fragments, you can see that we provide you with sample code fragments for Java and other languages down here. But I'm just going to say store. And now you can see that I have stored a password or a secret called smdemo that will contain the username and password that I had entered. Now I'm going to flip over to my console session over here. And one of the things you'll notice in this console window is that when I build the instance, I decided to create a couple of scripts that can help you to see what Secrets Manager is actually doing. Now we'll talk about the two MySQL scripts here. And the first one we're going to talk about is mysql.oldway.sh. So let me just cat that out so you can see what it's doing. And what it is doing, notice here that I have hard-coded the username and password in for the database as well as the endpoint. One thing to remember with the password, there is no space after the P. I made that mistake a couple times, so I thought I would point it out to you as well. And so this is just going to go into MySQL the way we would typically do it with a hard-coded password. And so if I say mysql.oldway.sh, hit enter, you can see that I've gotten a prompt. I'm going to say show databases, and I have a database here called smdemo. I'm going to say use smdemo, and then I'll do a show table so you can see what's in here. I have a table called book info, and I am going to select star from book info. And what comes back? A Tale of Two Cities from Charles Dickens. Okay, so I've been able to go in with a hard-coded password. Now, I'm going to do the same thing with the mysql.newway.sh, but actually let me go ahead and cat that out for you as well. So mysql.newway.sh. And here we're doing things a little bit differently. What we're doing is we are using AWS Secrets Manager to fetch the secret associated with this, with a secret value that is supplied as a command line parameter. And then we're using JQ to pick off various parts of this information to extract the username and password. Now, typically you would not use environment variables to hold usernames and passwords. That's not just it's not a generally good security practice to do so. But what we're doing is we're doing it this way just for the purpose of providing a demo. So now I'm going to do mysql.newway.sh, and I'm going to mention the name of the secret that I provided. So again, I am now in the database or in the database instance. I'm going to say use smdemo. And since I know what the table name is, I'll just say select star from book info. And again, you can see the contents. Now, in this case, I didn't use a hard-coded password. I used Secrets Manager to provide me with the credentials. And so you can see that we were, in fact, able to retrieve them and gain access to our database. Now, I gave you one more script here, and I just want to show what this is. Display secret versions.sh, and I'm going to type the name of the secret. And you can see here that I have one version of the secret with this long version string, and here is the username, password, and note the version stage here, which is AWS current. That's what I was talking about before with those labels, those staging labels, to help you determine what the current version is. Now what I'm going to do is I'm going to go into my secret, and I'm going to edit the rotation. I'm going to enable the rotation, and I'm going to set it to 30 days. I'm going to say use the secret, which means I'm going to use the credential in the secret to gain access to the database and then change that same credential. So I'm going to click Save here now. And notice that there is a message up here saying rotation is being configured. Stay on this page. This can take up to 2 minutes to complete. What's happening here is the console is initiating a connection to the Secrets Manager API to perform this rotation. It's doing this on your behalf behind the scenes, but it's important that you not leave this page while this rotation is happening. It says that it can take up to 2 minutes to complete, but in practice, what I've noticed is that it actually tends to take under 1 minute to complete for a database like this one. So we should be able to see this happen very soon. And yes, the secret has been stored and rotated. It has generated a new value. Now with some browsers, there are things that are cached. So I'm going to just refresh my screen to make sure that we have the most current credentials. And if I retrieve my secret, I can actually see that my password has in fact changed. It now starts with a B and ends with an M. Now, let's go back to my console window. Now, if I run the old way script with the hard-coded password, this should fail, and it does. It says access denied because my hard-coded credential is no longer working. So now if I say mysql.newway and I specify the parameter or the secret parameter, you can see I am back in my database because what Secrets Manager has done is that it has fetched the new value of the credential, and I can say again, use smdemo, select star from book info, and again, I see that I have access to the table just like I did before. Let's quit out of this and let's do one last thing. Let's run my display secret versions.sh file. Whoops. And I have to specify a demo or a secret name. Notice now that I have two versions. My new credential, I have the username, my new password that begins with a B and ends with an M. And this now has the AWS current label as well as the AWS pending label. Remember what I said about rotations. First, Secrets Manager attaches the pending label, it tests the new credential, and then it moves AWS current to it as well. And my previous credential is now stored with the AWS previous staging label. So now you see how Secrets Manager works to enable you to fetch the value of a secret. We've shown how you can use Secrets Manager, how you can retrieve values from it to access a database. And we've also shown how you can look at the different versions of a secret and see the different staging labels such as AWS current, AWS pending, and AWS previous, so you can see both the current and the previous versions of a secret. I'd like to thank you for watching our webinar today. That concludes our presentation of Secrets Manager, and we're now going to close out our demo, and we're going to move to a period of questions and answers.